Lecture 2 of 4, Part 2. Topic 7.0 Trigonometric Functions. Subtopic 7.2 Compound Angle. Learning Outcomes. At the end of the lesson, students should be able to use the half angle formula and use the factor formula. Use the half angle formula. For any angle theta, we have sine theta is equivalent to 2 sine half theta cos half theta. This is coming from sine 2 theta equals 2 sine theta cos theta. Let theta as a over 2. So we will go to sine 2 times a over 2 equals 2 sine a over 2 cos a over 2. Sine a equals 2 sine a over 2 cos a over 2. As for cos theta, we have 3 equations for it. That is, the first one is cos square half theta minus sine square half theta. This is coming from the double angle of cos 2 theta equals cos square theta minus sine square theta. From the identity, we have cos square theta plus sine square theta equals 1. And cos square theta equals 1 minus sine square theta, and sine square theta equals 1 minus cos square theta. From this trigo identity, we can have the second equation for cos theta, that is cos square half theta minus 1, and the third one is minus 1 minus 2 sine square a over 2. While for the tangent theta is equivalent to 2 tangent half theta over 1 minus tangent square half theta. This is coming from the double angle of tangent 2 theta equals 2 tangent theta over 1 minus tangent square theta. Example 1. Given that sine A is minus 8 over 17 and cos B is 3 over 5, where A and B are in the same quadrant, find without using calculator A sine A plus B, B cos A over 2, C sine A over 2. Solution. Given sine A is minus 8 over 17 and cos B is 3 over 5. So if sine is negative and cos is positive, so A and B must be in the fourth quadrant. Now we go to refer to the angle A. So the given info is minus 8 over 17, minus 8 over 17 for the sine A. So therefore, this adjacent must be 15. And you can have cos A will be 15 over 17. 15 over 17. Now we go to refer angle B. The given info is cos B equals 3 over 5. So 3 over 5. So therefore, our opposite must be minus 4. So we have tangent B equals minus 4 over 3. And we also can have sine B equals minus 4 over 5. Minus 4 over 5. Now we go to find sine A plus B. equals sine A cos B plus cos A sine B. Okay, all this value you can get from just now's one. So we have sine A, we just substitute by minus 8 over 17, and cos B 3 over 5, and cos A we have 15 over 17, and sine B we have minus 4 over 5. Okay, and then we calculate this out, we will have minus 84 over 85. For B, cos A equals 2 cos square A over 2 minus 1. For cos A, we have the value minus 8 over 17. And then you can go to find cos A over 2. From this equation, you can have 2 cos A over 2 and 15 over 17 plus 1. We have 32 over 17. So therefore, we will have here cos A over 2. We have 32 over 17 divided by 2, and we square root outside, and lastly we will have plus minus 4 over 17. And from these two value for cos A over 2, we have to determine which one we should choose as for the answer for cos A over 2. A, we have A is 270 from 270 until 360. Because A just now is in the fourth quadrant. So therefore, what we want now is A over 2. A over 2 must be 270 divided by 2, we have 135, and 360 divided by 2, we have 180. So therefore, we should choose the negative one. From here, we should choose the negative minus 4 over 17. This is cos A over 2. For C, we have sine A equals 2 sine A over 2 cos A over 2. Sine A over 2, we have just now is minus 8 over 17, and cos A over 2 is minus 4 over 17. Just substitute these two values into this equation, so we will have like this. And lastly, we're going to have sine A over 2 is 1 over 17. Use the factor formula. For any angle P and Q, we have the first one is sine P plus sine Q equals 2 sine P plus Q over 2 and cos P minus Q over 2. The second one, we have sine P minus sine Q. Just now is plus. So we have 2 sine P plus Q, sine P minus Q over 2. 2 sine P plus Q over 2, sine P minus Q over 2. The third one is cos P plus cos Q. This is plus, equals 2 cos P plus Q over 2 cos P minus Q over 2. And the fourth one is cos P minus cos Q. We have 2 minus sine P plus Q, sine P minus Q over 2. Okay, so we have cos P minus cos Q is minus 2 sine P plus Q over 2, sine P minus Q over 2. What we have in common is that the first and also the second is sine plus sine and sine minus sine. The third and the fourth one is cos plus cos and cos minus cos. There is no mixture of sine and cos. Okay, now we go to the next part. Sine A plus B plus sine A minus B is equivalent to 2 sine A cos B. Sine A plus B minus sine A minus B is equivalent to 2 cos A sine B. Cos A plus B plus cos A minus B is equivalent to 2 cos A cos B. Cos A plus B minus cos A minus B is equivalent to minus 2 sine A sine B. Example 1. Express each of the following as the product of two trigonometric functions. A sine 6 theta plus sine 4 theta. B cos 8 theta plus cos 4 theta. C cos 7 theta minus cos 5 theta. And D sine 8 theta minus sine 2 theta. We will do the first one. Okay, remember that we want to have our last answer should be the product of two trigonometric functions. Sine 6a plus sine 4a. So we can apply this formula. Sine p plus sine q is 2 sine p plus q cos p minus q over 2. So we will have 2 sine p as 6 theta and our q should be 4 theta. So the first one is plus 6 theta plus 4 theta is 5 theta, or is 10 theta I mean. So over 2. So we have sine 5 theta times cos 6 theta minus 4 theta. We have 2 theta divided by 2. We will have cos theta. So you can see that sine 6 theta plus sine 4 theta is already becoming the product of two trigonometric functions. Now we go to B cos 8 theta plus cos 4 theta. So we can go to apply this formula cos P plus cos Q equals 2 cos P plus Q cos P minus Q over 2. So we have 2 cos 8 theta plus 4 theta for the P plus Q. We have 12 theta divided by 2, we have 6 theta here. And then cos 8 theta minus 4 theta is 4 theta divided by 2, we have 2 theta. So we can see that the addition of two trigo functions can be put into a multiplication of the two trigo functions, or a product of two trigo functions. What about minus? Cos P minus cos Q equals to minus 2 P plus Q over 2 and sin P minus Q over 2. So let's go and have a look at an example for this formula. So we have cos 7 theta minus cos 5 theta. We should have minus 2 sin P plus Q over 2. So we have 7 theta plus 5 theta, 12 theta divided by 2, we have 6 theta here. So minus 2 sin 6 theta, and here P minus Q over 2 is 7 theta minus 5 theta. We have 2 theta divided by 2, we have 1 theta. D, sine 8 theta minus sine 2 theta. So we have minus, we go to use the formula of sine P minus sine Q. So we have 2 cos P plus Q over 2 and sine P minus Q over 2. So just apply this formula. We will have here 2 cos P plus Q, 8 theta plus 2 theta will be 10 theta. Divided by 2, we have 5 theta. And sine P minus Q over 2 is 8 minus 2. We have 6 theta over 2, we have 3 theta. Example 2. Express each of the following as the sum or difference of two trigonometric functions. Okay, now this is multiplication of two trigo functions. A sin 6a sin 2a. So we can go to use this formula minus 2 sin A sin B equals cos A plus B minus cos A minus B. So this is equivalent to minus half cos 6A plus 2A. Okay, and then minus cos 6a minus 2a, so minus half cos 8a minus cos 4a. So this is a difference of two trigo functions from a multiplication of two trigo functions or a product of two trigo functions. Sin 3a cos A. So you can use this formula. Sin A cos B is half sin A plus B plus sin A minus B. So we have half sin A plus B. This is A, this is B, and then now with 3A plus A. Okay, so we have sin 4A plus sin A minus B. So 3a minus a, we have 2a. And the fourth one, 4 cos 5a cos 3a. So you can use this formula. 2 cos a cos b equals cos a plus b plus cos a minus b. So this is 4, this is 2. So there will be a little bit of reshuffling here. So we can bring this 2 outside and remain this 2, another 2, so that it can equate to this formula, the given formula, 2 cos A cos B. So we have 2 cos 5A sin 3A. I mean, here should be cos. So we will have 2 cos 5a plus 3, this is cos A plus B, so 5a plus 3a plus cos A minus B, 5a minus 3a. So we will have here cos here should be cos 2 cos 5a plus 3a is cos 8a minus cos 5a minus 3a will be cos 2a. Example 3. Find the exact value without using calculator. A, we have sine 105 degree sine 15 degree. B, sine 105 minus sine 15. We go to the first one. Sine 105 degree sine 15 degree. So we'll have here, use this formula, minus 2 sine A sine B equals cos A plus B minus cos A minus B. So we should go to have, what we want now is just sine A sine B. So minus 2 will be brought into this side. So we have minus half cos A plus B. So cos 120. And then minus cos 105 minus 15, we have cos 90. Equals minus half cos 120 is equivalent to cos 60, but 120 is in the second quadrant and cos in the second quadrant is minus, and cos 60 is half and cos 90 is 0. So altogether we'll have 1/4. Sine 105 minus sine 15. So we can go to use this formula, sine P minus sine Q. This is minus 2 cos P plus Q over 2 sine P minus Q over 2. So we will have here minus 2 times cos P plus Q. This is 120. Okay, 120 degree cos, okay, over 2. Sine 105 minus 15 over 2. So we have minus 2 cos 60 sine 45. Cos 60 is half and sine 45 is 1/2. Okay, so we cancel 2 and 2. We will have here minus 1/2. Example 4. Prove the following identities. A, sin 7a plus sin 3a over cos 7a plus cos 3a equals tangent 5a. B, cos 2a 2b minus cos 2a over sin 2a plus sin 2b is equivalent to tangent A minus B. Okay, solution. A, sin 7a plus sin 3a over cos 7a plus cos 3a is equivalent to tangent 5a. So we may start. The above one here, sin 7a plus 3a, using this formula sin p plus sin q equals to sin p plus q over 2 cos p minus q over 2. And the below one, we can use cos p plus cos q for cos 7a plus cos 3a equals 2 cos p plus q times cos p minus q. So we will have like this. 2 sin For the 7a, sine 7a plus sine 3a, we have 2 sine p plus q over 2. So 7a plus 3a, 10a divided by 2, we have 5a. Cos p minus q, 7a minus 3a divided by 2, 10. We have minus 7a minus 3a, we have 4a. 4a divided by 2, we have cos 2a. As for the below part, or in the denominator part, where 7 sine 7a plus cos 3a is 2 cos p plus q. So we will have here 2 cos 5a cos 2a. So it should be cos 7a plus cos 3a. So just follow this formula. We have 2 cos p plus q over 2 cos p minus q. So we will have here cos 7a plus 3a will be 10a divided by 2, so we have 5a. Then cos p minus q, 7a minus 3a, 4a. 4a divided by 2, we have 2a, so cos 2a. So what we can observe here is that we have something in common. That is cos 2a and also this cos 2a. 2 and also 2 also can be cancelled. The left behind one, known as sine 5a over cos 5a. Sine over cos is tangent, so tangent 5a. This is the right hand side. Okay, then we continue to prove this formula cos 2a minus cos 2b over sine 2a plus sine 2b equals minus tangent a minus b. Left hand side, cos 2a minus cos 2b over sine 2a plus sine 2b. So the above one, or the numerator, we can use this formula cos p minus cos q. That is minus 2 sine p plus q over 2 sine p minus q over 2. So we have 2 minus 2 sine p plus q, so we have 2a plus 2b divided by 2. Sine p minus q, 2a minus 2b over 2. Over, okay, the numerator one, we can use the formula of sine p plus sine q equals 2 sine p plus q over 2 and cos p minus q over 2. So we should have 2 sine 2a plus b, 2a plus 2b over 2 cos 2a minus 2b over 2. And then now we go to simplify. And sine a 2a plus 2b over 2, same as in the below part, so it can be cancelled. And also we have 2 above and below part, so it all can be cancelled. Okay, and then we'll have minus tangent. This is sine and cos. This is 2, same thing here. So 2 and 2, so it can be cancelled. Cancel this 2 and also this 2. Okay, and so for this one, cancel. So we have 2 and cancel here, minus tangent a over 2. Okay, so this is right hand side.